give me a break. The effects of brake fluid runoff on seed germination.
Oh yeah, sorry.
The everyday automotive chemicals used for maintenance, such as brake fluid, represent a major source of non-point environmental pollution. When leaked into driveways or disposed of improperly, these chemical fluids easily wash into the surrounding soil and local ecosystems through rainwater runoff. Toxicity threshold hypothesis, or the point where exposures become toxic. Our findings were that the seeds in the control group trial of 0% concentration will exhibit a normal germination process reaching stage 2. When we increase concentrations of DOT brake fluid, the germination rate and radical growth will not progress past stage 1, or seeds will remain at stage 0. The toxicity threshold where active root elongation comes to a halt lies in between 2.5% and 5%.
Ready? Okay. To model how runoff impacts plant health, this study evaluates the effect of DOT-free brake fluid on the germination rate and radical growth of radish seeds. According to chemical formulation data provided by Complex Chemical Company 2015, DOT-3 brake fluid consists primarily of a glycol ether base. By testing different variations of DOT-3 and concentration levels, the trial performed by this group may help identify the specific threshold at which brake fluid toxicity prevents normal seed development.
So this screen is just for pictures that we found during our trials that we thought were interesting or showed some type of possible discrepancy. Over here on the left we have a picture from Jenna, her day 5% brake fluid concentration baggie. These seeds are showing signs of phytotoxic damage, specifically a loss of structural integrity and hollow tissue. They seem to just fall apart, and I also noticed that in my trial as well. This middle picture is also from Jenna, her day 5 0% brake fluid concentration bag. Here you can see radical elongation showing strong beginning root propagation. As you can see, the roots are starting to extend, starting to, propagate. The top right picture is my picture from my day 5 0% and 1% brake fluid concentration baggies. Here we see a possible discrepancy in the trial where the 0% radicals are presenting as more wilted and brown, and the 1% growth is stronger, thicker, and brighter, when really it should be the opposite. And then on the bottom right, we see another possible discrepancy in Cassie's bag of day 5 10% brake fluid concentration, where half of her 10% brake fluid seeds were showing growth, and the rest of our 10% brake fluid seeds were showing none. And then here we have our graph that we made. It's just the average seed germination affected by different brake fluid concentrations across our 3 separate trials. So we have average number of seeds and the brake fluid concentration from 1 to 10%. Down at the bottom, you can see the key that shows the 3 different stages that our seeds went through. We have our dormant unchanged, that's still in the seed, still in the casing. Stage 1 germinated, where the growth starts, and then all the way to stage 2, where the radical begins growing. Some key findings: as the levels of brake fluid increase, we notice that the seed growth did decrease. So you can see that where in our 0% and our 1%, it's more pink, and then as we increase the brake fluid, it starts to turn blue and then green, showing that there's less growth. So the seeds that did germinate were the seeds that did germinate while experiencing toxic levels of brake fluid were found to be darker and more shriveled across all 3 trials. with some discrepancies, including one trial's 0% concentration bag failed to reach 100% stage 2 growth, and another trial's 10% concentration seeds shown 50% stage 2 growth.
Is this me?
I think so.
We're already at 7? Holy God. Okay. So some of our key findings that we had, these cute little pictures up here of this seed, they are actually a soybean seed, but the radish does pretty much the same thing. And we've seen that, and all of you've seen it too in your experiment. So the findings show that increasing concentrations of DOT3 brake fluid decreased germination rate and radical growth. The toxicity threshold where active root elongation comes to a halt lies between 2.5% and 5% as predicted. The control group established a normal baseline, achieving 100% germination with normal radical elongation reaching stage 2. But exposure to even minimal amounts of DOT3 brake fluid disrupted normal growth, and the germination process became stunted, not progressing past stage 1. Higher concentrations remained dormant at stage 0, where seedlings exhibited minor coat splitting but did not progress past stage 1 throughout the 5-day period, confirming our toxicity threshold hypothesis. And one thing on here I noticed in our slides, but we had, I go back up here, right here, in our key, this is how we basically documented everything, going from, so we would make notes just with like stage 0 being, they didn't do anything, or they might have done something, but they remained unchanged, pretty much in the seed coat. And then we have stage 1, when we say stage 1, this is what we're talking about, like that they started the germination process. And stage 2 was the radical elongation, where the radical started emerging and then actually had some length to it. So we said different stages throughout this, but we really didn't explain to you what we were talking about. So I just wanted to clear that up. All right, I'm done. Moving on. There's our references. Beautiful. Okay. Thanks for joining us, everybody.